Students, today we begin what I consider kind of the first topic in chemistry, elements and compounds. We've been talking all about the building blocks of chemistry, really, until this point. I think this is one of the most exciting topics because it will set the stage for teaching us a new language, the language of chemistry. So, as we get ready to learn about elements and compounds, let's get our books ready and get started with our notes because we're going to have a lot of fun this week with the topic elements and compounds. Now, both elements and compounds can both be considered pure elements. Pure elements are made of only one kind of material and have definite properties. Now, that one kind of material we could recognize physically by looking at a substance and seeing that it's uniform or homogeneous throughout. That's what we're talking about when we talk about one kind of material. But as we go through this topic, you will discover that elements are made out of smaller material, and those things are made of smaller materials, and certainly compounds are made of smaller materials. But the point is, with pure substances, when we talk about one kind of material, we're talking about something that is uniform throughout. And these definite properties are unique to that pure substance. There are certain definite properties or characteristics or traits that are unique to elements as well as to compounds. And no matter where that element or that compound exists on Earth or in the universe, those properties or characteristics are also uniform or consistent with those materials. So let's begin our discussion of these pure substances by mentioning the elements. Now, if you've checked out the notes online already, you've seen this link to the various elements. We now are in most agreement in the scientific community that all 118 elements have been identified and discovered. When I was your age, there were a lot fewer elements. There were empty spaces on the periodic table. Not so anymore today. It is believed by most that the periodic table of elements is complete. In fact, we're going to spend a whole week in the near future talking about the periodic table, and we'll get into that a little bit more. But while we're working our way up to that, and while we're on the subject of elements, I want to offer you some bonus point opportunities. And these bonus point opportunities lie in the learning of a song. And this song is called the Periodic Table Song. If at any time this year, not just today or this week, this year, you are able to memorize this song and sing it, and you could create a music video of you singing this song if you wish, I will give you a 100 grade for your lowest quiz. In other words, I'll replace your lowest quiz score with a 100. I would love for you to learn the periodic table song. So how does it go? Well, give me a couple minutes here for you to listen to the periodic table song. And certainly you can listen to it over and over and over again until you learn it. I know many of you have many songs memorized, so why not add another to your vast repertoire of musical knowledge? So here it is.
And now, ASAP Science presents.
I'll start that over again. Here we go. I just had to turn the volume up.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, no gas is stable. Halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get. Copper, zinc, and gallium, germanium, and arsenic. Selenium and bromine film, while krypton helps light up your room. Rubidium and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun. Lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62. Samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead that is knit for your tummy, polonium, astatine would not be yummy, radar, francium will last a little time, radium, then actinides at 89. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells where electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, bromium, and nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, obsidium, rhenium, copernicium, natrium, flerovium, pentium, livermorium, septium, unimoctium, and then we're done. Like the song? Be sure to check it out on iTunes and Bandcamp. Links are in the description.
Wasn't that a lovely song? The periodic table song. By the way, it has to be updated. The song has to be updated because there were several elements towards the end of the song which now have names. They have been given names, official names, since the time this song was made. So maybe you can check out on YouTube an updated, revised, and complete version of the periodic table song. So again, that offer stands throughout the year if you can sing this song. And by the way, you don't have to sing it quite as fast as this version, but if you can sing the song, maybe videotape yourself doing it, I'll replace your lowest grade with a 100. So let's continue now with elements. We just heard the song about the elements. Well, what are they? They are the simplest of pure substances. Again, pure substance, one that is the same throughout. So elements are the simplest pure substance. And elements are made out of atoms. Atoms, as you know, are the basic building block of all matter. They are the simplest part of an element, and I'm going to add something to that still retain the characteristics of the element. So you can take an element, let's say the blue element, and you can break it apart into its components, and each of these components, which we'll call atoms, still retain the characteristics of that element. Now, we'll learn in the future that even individual atoms can be broken down even further. That'll be a topic in the near future. But for now, we're talking about pure substances. Atoms, the basic building blocks of all matter, are the simplest part of an element that still retain the characteristics of that element. That is a very important point. Now, I mentioned in the intro that we would be learning a new language this week, and that is pretty much true. And as you know, with any language, whether it's English, Spanish, German, or what have you, languages begin with an alphabet. In our alphabet, we have A, B, C, D, E, F, G. And now I know you're dying to sing the rest of the song since I planted that tune in your head. And music has such powerful abilities in your memory. So why not pause this video and sing the ABC song? All right, hopefully you got that out of your system, and now it's time to learn the ABCs of chemistry. And those ABCs begin with things called symbols. Symbols are the shorthand way of writing elements. If you look in your book, you have a couple of them, one in the middle of your book, one in the back of your book. If you look in any science lab, like here at the school, you'll see posted a periodic table. You just saw the periodic table song. And in that song, you saw various squares with symbols in them. Every element is abbreviated with shorthand in a symbol or with a symbol. Now, all of the elements have their own unique symbol. And let me just mention something about symbols right now. This is very important. As you may remember from last year when we learned about genetics and dominant and recessive traits and how important capitalization is, well, it's just as important here in physical science in our study of chemistry and our knowledge and use of symbols. Capitalization is very, very important, as we will discover throughout the remaining topics of this unit. Symbols always begin with a capital letter. If a symbol only has one letter, that one letter is capitalized. If a symbol has two letters, the first letter is always capitalized and the second letter is always lowercase. Now, as I mentioned before about that song, some of the latter elements in that song actually had three symbols, you'll notice. Those three symbols are no longer in existence. We now have names for all of those elements, and the symbols are only two letters. So we can safely say now, as of the time of this video, that all elements are symbolized by two letters. The first letter is always capitalized, and if there is a second letter, the second letter is always lowercase. You might want to add that as a note in your notes for future reference, because we're going to be drawing upon that knowledge that I just imparted to you now. So elements are made of atoms, and elements are symbolized by symbols. Now, the other pure substance that we are making reference to here are called compounds. Compounds are pure substances that are made of more than one element, and they are chemically combined. I emphasize that word chemically. As you remember, we just finished up our topic of mixtures and solutions. And mixtures, as you recall, are substances that are made of more than one material, but they can be physically separated. They can be taken apart using physical means. You cannot do that with a compound. I'll give you an example. Water is an example of a compound made of hydrogen and oxygen. If it were a mixture, you could use your fingers or do something to separate out the hydrogen and the oxygen elements. You can't do that because water is a compound and they are chemically combined. Now, can you separate the hydrogen from the oxygen in water? Yes, you can. You just don't do it through physical means. You have to do it through chemical means. And that's one of the things we're going to be doing this week. We're going to be exploring the changes that can take place between elements and compounds. We're going to make some compounds, for instance, this week in the laboratory, but we're going to use chemical means to do so, not physical means. So, as I just mentioned, compounds can be chemically broken down. Unlike what I might illustrate here with my building blocks, let's say we've got a blue material and a yellow material, which looks kind of funky with the green screen behind. You can physically take these things apart and they each retain their individual identity, like we talked all about last week with mixtures. Compounds, you can't do that. Compounds, you've got to break them down chemically. Now, what exactly does that mean? Well, hold on, because we're going to get to it. We're going to get to it over the course of the next few weeks. We have to have a little bit more understanding in order to really grasp what that actually means. Now, as I mentioned to you a moment ago, elements are made of their building blocks called atoms. Compounds also have building blocks that they are made out of, and they are called molecules. So elements are made of atoms, compounds are made of molecules. Molecules are the smallest part of a compound that still retain or keep the characteristics of that compound. If you break a molecule up, first of all, you have to do it chemically. And second of all, you'd be breaking that molecule down into elements. And elements would no longer retain the properties of the compound that they make up. So elements are made of atoms. In fact, in your notes, circle elements, circle atoms, draw a line between them. So when you are studying for the quiz this week, you can remember that elements are made of atoms. And also in your notes, while you're circling things, circle compounds and circle molecule and draw a line between them so that you can remember and study that compounds are made up of molecules. Okay, so these are the two types of pure substances that exist in the universe, elements and compounds. So here we have a quick little visual which may illustrate that atoms are the smallest, then we have elements, then we have compounds and molecules. That's really not a great diagram now that I look at it. So let's move on to the next one. All right, so here we go. We are well on our way to learning the language of chemistry. We now know what the alphabet of chemistry is made up of, the elements. And in your book, I am encouraging you to learn a list of elements that are the common basic elements that we'll be using throughout the rest of this unit. So I encourage you to study the name and the symbol for those elements that I've listed for you in your book. Because when you put elements together, we can create what are called chemical formulas. Chemical formulas are the shorthand for writing chemical substances. In other words, they're kind of like words in chemistry. So if you like language arts and you love playing around with words, well, you're going to love chemistry, because once you've learned the alphabet of the symbols and you understand how those symbols representing elements can come together to form words, which we call chemical formulas, this is where the real fun of chemistry begins. So here are some examples for you of common materials that you're familiar with from the lab. And these are their chemical formulas. Let's start with probably the most famous chemical formula of all, H2O. Who can tell me what is H2O? Just say it out loud. You know it. Water. Yeah, that's water. H2O is water. Most people know that. H2O is water. Well, H2O is the chemical formula for water. Not only does it show us that that's the word for water in chemistry, but it also reveals some other very important information, as we'll discover in just a moment. But let's look at these other ones first. NaCl. Do any of you know what NaCl is the formula for? Some of you may know it. Salt, otherwise known as sodium chloride. Salt is sodium chloride. How about the next one here? CO2. This is probably the second most famous formula next to H2O of a compound. CO2, I'm sure you know what CO2 is. I'm breathing a lot of it out right now. Yep, that's carbon dioxide. Carbon dioxide. How about this last one here? Anybody know what this one is? We'll actually be using it in the lab in the future, but HCl. HCl. I'll give you a hint. It's a type of strong acid. It's hydrochloric acid. HCl, hydrochloric acid. So here are some common examples of formulas, and you're going to become very familiar with these formulas and other formulas as well as we proceed through this topic this week. But let's continue by my showing you some of the information here that can be found in a formula, namely what's called the subscript. That little number 2, H2O, that subscript explains to you or shows you or illustrates to you some important information. It tells you how many atoms of a particular element there are in a formula. Let me try and illustrate it to you. I'm going to pretend here for a moment that the little spheres that I have represent elements. And let's say the white sphere represents oxygen, and the yellow one here represents hydrogen. Now, I know based on where I hold it, it may look transparent, but it's a yellow with red stripes here. We're going to say that this one is hydrogen and this one is oxygen. Now, this chemical formula for water is telling us something very important. You see that subscript of 2, which immediately follows the symbol H, which is the symbol for hydrogen, as you probably guessed, tells us how many atoms of that hydrogen there are. So if I were to build a little model of H2O or water for you, it might look like this. Each of these 2 spheres, which represent hydrogen, there are 2 of them. Now, oxygen in the formula has no subscript after it. And so whenever you see a chemical formula with no subscript following a symbol, what that means is there is an implied 1. I mean, after all, if there were 0 of them, it wouldn't be in the formula at all. So if there's no subscript written here after a symbol, there's always an implied subscript of 1. So how many oxygen atoms do you think there are in H2O? You can see it. There's 1. So H2O not only is the chemical formula for water, it also tells you the ingredients of water. It tells you that there are 2 hydrogen atoms and 1 oxygen atom. And of course, you have to know what the symbols represent. You have to know the alphabet in chemistry. But now we've put letters together with a subscript, and we have formed a word or a chemical formula, which is the formula or the recipe for making water. In fact, before too long, we're going to use this recipe for water, and we'll make some water ourselves using the formula or the recipe for making water, believe it or not. So we've talked a lot about the foundational material here for chemistry. It might be a little bit much for some of you to absorb. So I'm going to ask you to take the remainder of our time today to go into your book and look over that common list of elements and start studying them now. It's never too early to start studying them. And then tomorrow, we'll pick up this topic and learn about how we turn words into sentences and complete thoughts, or to use chemistry lingo, to turn formulas into equations. So study those elements for the rest of our time today, and for now, I'll say bye-bye.